Good day, viewers all over the world. You are welcome to Toydale online class. Today, we want to start another concept in mathematics, which is called differential equations. If you check some of my videos under life, we've actually discussed about calculus. And we said calculus is of two types. We have differential calculus and integral calculus. So, under calculus, we have integration and differentiation. So we have a lot of videos on differentiation and integration. So today we want to build on differential calculus, which is an extension, differential equations, which is an extension of differential calculus. What is differential equation? A differential equation is an equation involving an unknown function and its derivatives. That is, if y is a function of x, the rate of change of y with respect to this x will be dy dx. This will be f prime of x. This will be the derivative of this unknown function y. Y is dependent variable, yx is independent variable. So this is the function and this is the derivative of the function. If you know a function and you want to get the derivative of the function, you differentiate that function. And if you know the derivative of the function and you want to get that function, you integrate the derivative. So whenever we integrate the derivative of a function, we are going to get that function plus a subsidiary conditions. So plus subsidiary condition, which is maybe we call it arbitrary constant. You understand? So this is a function and this is derivative of a function. So a function could be, when you say a function, it could be equal to so many value. It could be trigonometric function, it could be exponential function, it could be transcendent function. We have so many functions. Okay, we have so many functions. So when you have an equation that involves an unknown function, in this case we call the function y, which is dependent variable, and its derivative, it is called differential equation. Such an equation is called a differential equation. Such an equation is called a differential equation. So the following differential equations involving an unknown function y, these are examples of differential equations. This is the first one. Dy dx is equal to 5x plus 3. Dy dx is equal to 5x plus 3. That's the first equation. Then the second equation, we have exponential y, the square y over dx squared, plus 2 dy dx all squared is equal to 1. That is equation 2. Then we'll check this equation 3. That's where we have, these are partial derivative. We have di square y all over di t squared minus 4 di square y all over di s squared is equal to 0. So example 1 and example 2 are ordinary, or they are example of ordinary differential equations. Then example 3 is an example under partial differential equations. So example 1 has just, example 1 and 2 has just one dependent variable, which is x. But when we go to this example 2, this is partial differential equations. It has one unknown function y, which is dependent variable, but two different independent variables. We have t and we have x. So example 1 and 2, they are example under what is called ordinary differential equation. While example 3 is example of partial differential equations. So let's take note of that. So under differential equations, we have about 5 different types of differential equation. We can have delay equation, we can have stochastic equation. But for the purpose of this lecture, we just want to introduce differential equations. We want to introduce differential equation, and this is differential equation. Example 1 and 2, they are under ordinary differential equation. Then example 3 is where we have partial differential equation. So let's take note that when you have an equation that involves an unknown function and its derivative, it is called a differential equation. So for the purpose of this class, we only talk about 2 types of differential equations. We have so many types. So we can have delayed differential equations. We have so many types of differential equations. We can have stochastic differential equations. So we have so many types. But for the purpose of this lecture, we only talk about 2 types. We only give example on 2 types of differential equation. The first one that we are going to talk about, is called the first one, types of differential equation. Types of differential equations. The first one is called the ordinary differential equations. The abbreviation is ODE, ordinary differential equations. We only talk about two, ordinary differential equations. So a differential equations is an ordinary differential equation if the unknown function depends only on one independent variable. That is, under this ordinary differential equation, the dependent variable depends only on one independent variable. For instance, where we have the y, dx, which is same thing as 5x plus 3. If y is a function of x only, then when we find the derivative f prime of y dy dx will only be f prime of x. So in this case now, dependent variable depend on only one independent variable. Then this example of differential equation is called ordinary differential equation. And this ordinary differential equation is of order 1. It's only the y dx that we have there. It's order 1. Okay. So example, that's example. Then 2, where we have partial differential equations. Under this, because it is the abbreviation is PDE, partial differential equations. So what do we understand by partial differential equations? Under partial differential equation, we know that if the unknown function depends on two or more independent variables, then the differential equation is a partial differential equation. Like the example I gave the other time, where we said the square y all over di t squared minus the square y all over di x squared is equal to 0. So when we look at this second example, you realize that in this case now, y is a function of both c and x. So this second example is a function of more than one independent variable. C is an independent variable, this x another independent variable. So when you have a differential equation in which the dependent variable depends on more than one independent variable, then it's called a partial differential equation. Like this example, y is a function of both x and t. It is even possible to have y to be a function of both c, x, and y. It can be more than 2. So whenever we have that the dependent variable depends on more than 1 or 2, more than 2 or more independent variable, then such differential equation is referred to as partial differential equation. So let's take notes. As I've said earlier on, we have more than 2 types of differential equations. We can have delayed differential equations. We can have stochastic differential equations. But for the purpose of this class, we are going to restrict the type of differential equation into 2: ordinary differential equations and partial differential equations. That's what we'll be talking about. So in our next class, we are going to talk about how to find the order of differential equations and the degree of differential equations. So today we have been able to talk about the definition of differential equations, and we define differential equation as an equation involving an unknown function and its derivative. So unknown function and its derivative. Then we talk about types of differential equation. We only talk about 2: ordinary differential equation, in which we have the dependent variable to depend on only just one independent variable. For instance, dependent variable is y, independent variable is x. Then under partial differential equation, which is the second type of differential equation that we talked about, we have the unknown function y that depends on 2 differential independent variable, c and x. So I'd love to stop here. We continue in our next class. Thank you.